Hello. You can. Are you first years? Which year are you in? Year two. You taking my course or not?
No, we're not.
Oh, okay. Hello guys. Where are you? Can you do question 1 please? Question 1. Question 1 in the sheet here. This sheet is on two sample tests. Yeah, just for practice. So can you do question 1 please? This is so this exercise sheet is on 2 sample tests, which we covered about 2 weeks ago. I think we covered this stuff about 2 weeks ago. So you should go to the course website. You will see. You should go to week 10. You should go to week 10. You will see the stuff that we covered. So let me show you. This is the stuff that we covered about 2 weeks ago on 2 sample tests. Right? To do question 1, you need to use one of these 3 rejection rules, right? So choose the correct one, and apply it to do question 1. Okay, can you do that please? By the way, this the exam next week will not will not contain this material, right? Will not contain two sample test or two sample confidence intervals. Nevertheless, we will do this just for practice. We are doing this just for practice, right? Okay. All right. So to do question one, you need to use one of the three rejection rules on the screen, right? So you use one of the three rejection rules on the screen to do question one. Alright guys, so which rule you think we should use? Is it 1, 2 or 3? Which one you think we should use? Hmm? Come on guys. Some of you say 1, 2 or 3. It should be huh? Come on, tell me one answer. 2, yeah. Okay, we will use the rejection rule 2, yeah? So you have, so this is, excuse me, this is question 1, part 1, okay? So you're testing your null hypothesis is mu1 equal to mu2 versus the alternative is that mu1 greater than mu2. And the rejection rule that we are going to use is x bar 1 minus x bar 2 divided by sigma 1 squared so this is the rejection rule, right? So what I'm going to do now is to compute the left hand side and compute the right hand side and see if this inequality is satisfied, right? So the left hand side is 11.4 minus 9.9. Sigma 1 squared is given, which is 6.25 divided by n1. n1 is 10. Sigma 2 squared is 9 divided by n2 is 12. So if you compute this will be 1.279. The right hand side we are using alpha is 5%, so the right hand side is z 0.95, which is 1.645. So this is the right hand side, this is the left hand side, and clearly the left hand side is not greater than the right hand side. So the conclusion is that there is no evidence to reject H0, right? Yeah. All of you got this right, yeah? Yes? Okay, now part 2. So this is part 1. You guys okay with this? Yeah? Alright. So let's do part 2 now. Part 2 of question 1. We want to find the probability of rejecting H0 when the true difference between mu1 and mu2 is equal to 2. Right? Now, we know that the rule for rejecting H0, this is the rule for rejecting H0, guys. Right? So which is, let me write it down one more time. It's going to be x bar 1 minus x bar 2 divided by sigma 1 squared, which is 6.25 okay, this is what you get. Okay, now we need to work this probability. Now this statistic is based on the assumption that the difference between the true population means is equal to 0, right? So in order to, so what I'm going to do next is I'm going to subtract 2. You see in a minute why I'm doing this. right? You see why I'm doing this? Because the true difference between the population means is now equal to 2, not 0, right? Okay? Now, in the next step, I'm going to take this guy here to the right hand side of the inequality. Now, so this will become right. Now, conditional on this, conditional on the true difference between the population mean being equal to 2, this will have the standard normal distribution. That's because of one of the properties that we talked about earlier. If you watched the video on the normal distribution, you will see this property that conditional on this has a standard normal distribution. Right, so you can write this using that property. You can write this as n01 greater than 1.645, take away 2 divided by 6.25 divided by 10 plus 9 divided by 12. Okay, now we don't need the conditioning anymore because we have used it, right? And this probability you can write it as 1 minus the probability that n01 is less than or equal to this, which is simply phi or phi at 1.645 minus 2 divided by okay. And if you work this out using the tables or using the ARA software, this will become equal to 0.52. So this is the answer to part 2. This is the answer to the probability of correctly rejecting the null hypothesis when the true difference is 2, right? Is that okay, guys, or not? Okay. Can you do now question 5, please? Question 5. Question 5 on the exercise sheet. For question number 5, you need to use a different set of formulas. I will show you what they are. Just let me show you where they are. So the formulas that you need to use for question number 5 are these ones, right? Here, question number 5, we are testing for equality of population proportions. right? So you need to use either this one or this one or this one. So one of the three you need to use, right? So, so which roll do you think we should use? Is it 1, 2, or 3? Huh? you can use choose as you would like. Then use choose. But the thing is, it's high. It's asking, yeah, okay. The population who will be living in Australia is higher among those who have 100 college than among those who have none. Yeah, you can use two, yeah, you can use two. So that, yeah, I think this is correct. This is correct. Yeah. Yeah, you may come with exams, but you don't need to remember anything, any formula for the case high school. But you may still come with exam. So if it comes in the exam, then I'll give you the formulas you need to remember for the class. If it comes, if it, we know the formula sheet you need to remember. The formula sheet. It's not, that's why it's not in the formula sheet. That's it's not a formula sheet. But if it comes, if that distribution comes, then I will give you the formula. There are, you need to know how to derive the one side. Yeah, I think there are four one side constants. One is the population mean, one is variance is not, one is variance is not known, and there is one for the population variance, and there is one for the population proportion. There are four constants in those. You need to know how to derive it. Yeah, you don't need to know two samples. We have only one sample. You need to know. You guys okay? Yeah. Yeah, I think that did a mistake. The answer did a mistake. I'll show you what. I'll show you later. Did you guys done? Have you guys done number 5? You have. Yeah. Let me show you Let me show you how to do question 5. So you can do it in different ways. Oh, let me change the camera. I need to change the camera now. Sorry. Okay. So this is question 5. All right. Let's take P1 to be the proportion of people believing in extraterrestrial but did not attend college, right? And let P2 denote the same thing for but did attend college. Okay, so the hypothesis that under this definition, the hypothesis that we want to test is is P1 equal to P2 versus P1 less than P2, right? So under this, for this kind of hypothesis, if you look at the rules that I showed you a few minutes ago, the rejection rule is if so is it greater than or I think it's less than, right? It should be less than minus z1 minus alpha. This is the rejection rule, right? So you should compute the left hand side of this, right? The left hand side is the proportion who did not attend school and believe in extraterrestrial is 37 divided by 100. The sample proportion for those who did attend college and believing in extraterrestrials was 47 divided by 100. Right? So this is the difference, and you divide that by right, you will get this to be minus 0.4133, and the right hand side is minus 1.645, right? And clearly minus 1.33 is greater than minus 1.65, so this rule is not satisfied. So the conclusion is that there is no evidence against. I think the typed solution has a mistake in it. It should say there is no evidence against H0 because the rejection rule is not satisfied, right? Okay guys, is that okay? Question 5. Yeah? Alright, now can you now do question 4 please? Question 4. Question number 4. So we have done question 1, question 2. Can you do question 4? I think we have time. We still have time. Can you try to do question 4 please? Question 4. For question 4, you need to use the following rules. Let me show you the rules that you need to use to do question 4. You need to use one of these rules in order to do question number 4. Right? You need to use one of these rules to do question 4. So it's either this one or this one or this one of these 3 rules. Yeah, A is given by the formula there. Yeah, it's very complicated. So what you should do is because the sample sizes are large, larger than 25, you can approximate this by exact percentile.
I think it's
Exact. So instead of this one, you will read exact 0.995. So there's only the sample sizes are greater than 25. In this case, 49 and 64 are greater than 25. Okay.
it's greater than it's very large. It's greater than 25. So
Yeah.
I need to find the
Yeah.
probability of that.
Yeah.
Okay.
Alright guys, let's see how we can do this question number 5. Sorry, question number 4. So here, alright, but which of the 3 rules do you think applies here? Is it number 1 or 2 or 3? Hello guys, question 4. Is 1, right? So you're testing whether the population means are equal versus they are not equal, right? So the rejection rule that we need to use, is number 1, which is we reject H0 if the absolute value of x bar 1 minus x bar 2 divided by is greater than T A 1 minus alpha by 2, right? Oh, sorry, I'll put the thing on. Okay, so you can see what I'm writing now. Okay, now let's compute the left hand side. The left hand side is gonna be, the left hand side is x bar 1 is given as 9.8, x bar 2 is given as 11.9 divided by S1 is 2.9 squared divided by N1 is 49 plus S2 is 4.2 squared divided by N2, which is 64. Right, now if you work this out, this will be equal to 3.14. Correct me if I'm wrong, right? So that's the left hand side. Now the right hand side, we are using alpha is 1%, which means if alpha is 1%, 1 minus alpha by 2 is gonna be 0.995. Okay, so the right hand side is gonna be the percentile of a t given by this. Now the formula for A, as you saw a few minutes ago, that the formula for A is very complicated, right? It's very complicated. So in a situation like this, if the sample sizes are 49 and 64, if the sample sizes are greater than 25, then you can, I think I mentioned this before, you can approximate the t percentile by the z percentile. So what I'm going to do here is I'm going to say that this is approximately equal to the Z percentile at 0.995. That's because the sample sizes are large. I mean, anything greater than 25 is considered large in statistics, right? Okay. Now you can read this easily from the normal table, and this will turn out to be 2.576. So this is the right hand side, and this is the left hand side. So clearly the left hand side is greater than the right hand side, so the conclusion is that there is evidence against the null hypothesis. All right? Is that okay, guys? This is question number 4. So, you guys okay? Are you okay with this or no? It's not an integer issue. Round it up to the nearest one. So it's 4.291. You can round it to 4. Yeah, fine. Okay. Yeah. Yeah, I made a substitution here to get to this, and then this is gamma 2 by 2, which is 2 pi by 2. Gamma 2 by 2 is 2 pi 1 by 2. And the gamma function. And the same thing here, this is gamma function. I think it is in the formulation, right? We need to remember, if you look at the formulation, I think this is the gamma. I think you need to remember that. Yeah, see this here, the gamma function. You need to remember this for the exam. Yeah. And also you need to remember that gamma of n is n minus 1 multiplied of n is positive. Yeah, you will get partial credit. Okay, guys, so this is the last tutorial. So tomorrow there will be a revision session. Tomorrow from 10 to 11. I will have a revision class, so please bring all the questions that you have for tomorrow. And also, you don't need to wait till tomorrow. You can email me 24/7 for any questions you have. And also, you can call me by Skype or Zoom, or you can come and see me in my office. My office is in Alan Turing 2.223. I'm usually in my office until 6 p.m. every day. So you can come and see me. You don't need to make an appointment to see me. Just drop by. I'll be happy to help you. All right. Okay, guys. So I'll see you guys tomorrow. Between at 10 o'clock. Okay. And if you haven't submitted the art coursework, please do so. Okay. The deadline is 11 o'clock tomorrow, as you know. Right. See you. See you guys. Bye.
Thank you.